Hey there, math magicians. Welcome to lesson 2. Hopefully you did all right on lesson 1, and we have some notes for you on complementary and supplementary angles. If you want to get your notebooks out and start taking notes, you can press pause at any time. And if you have any questions, please send me an email or a comment on Google Classroom. Here we go. So like I said, the title of lesson 2 is called Complementary and Supplementary Angles. And if I go too fast, again, you can pause the video and copy down what you need to. I tried to pre-write some notes to try to shorten the video for you. Here we go, complementary angles. Complementary angles are two angles that will add up to equal 90 degrees. So a 30-degree angle and a 60-degree angle together add up to equal 90. Therefore, they are considered complementary. Or the 30-degree angle would be the complement of the 60-degree angle because they add up to equal 90 degrees. Supplementary angles are defined as two angles that add up to equal 180 degrees. Remember, 180 degrees is a straight line. And so two angles that add up to equal a straight line are considered supplementary angles. Quick example here. If one angle measures 55 degrees, then the supplement would be found by completing this process. Since we know supplementary angles add up to equal 180, we would say that 55 plus the unknown angle will add up to equal 180 degrees. And when solving this one-step equation, we could subtract 55 on both sides to find that the supplement x is going to equal whatever 180 minus 55 is, which I believe, my mind just went blank, is 125 degrees. All right, because 125 plus 55 add up to equal 180. They are supplements of one another. The next little example that I have here for you is if an angle measures 22 degrees, the complement would be found by, well, complement means complementary angles, and complementary angles add up to equal 90, so 22 degrees plus, we could call it y, will equal 90 because they're complements. And again, this is a one-step equation, so you subtract 22 from both sides to get the complementary angle y to equal 68 degrees. So that's the complement of 22. All right, moving on, just a quick review of this type of equation of 6x plus 3x equals 45. You can see we have two terms here that have a variable on the same side of the equal sign. So 6x and 3x are on the same side of the equal sign. So we can combine these like terms, 6x and 3x. If we add those together, we get 9x equals 45. And this is multiplication, so to undo the multiplication, we would divide both sides by that coefficient of 9, dividing by 9 on both sides. And that would give you the value of x, which is 5. Just a quick review of solving equations, because we'll be setting up some equations that look something like this here in a few minutes. All right, I'm going to turn the page. And the next part that I want to put into your notes is this up here about angle addition. It says angle addition, it can be used whenever the angles are adjacent. Hopefully you remember adjacent pretty much just means that they're next to each other. Remember they share a vertex and a common side. So it can be used when you have adjacent angles and when you know the total angle measurement. So here's an example that kind of fits that description. And again, if you want to pause the video and draw this picture, that might help you. So then you can listen with your picture already drawn. Okay, so I assume you drew the picture out. Here in this picture we have angle XWZ, which is this entire angle XWZ, and in the picture it's labeled as 85 degrees. So I'm just going to label it over here as well so we have all of our information kind of organized. XWZ is 85 degrees. This is kind of the given information. I'm just kind of organizing it off to the side because our goal here is going to be to figure out what's the missing measurement for A right there. Okay, so here we have angle XWY, which is XWY, labeled in blue with 50. And then the last part is YWZ. YWZ goes YWZ, and that's this little part A. And that's what we're trying to figure out. So using the angle addition idea, let me find a color I can use, sorry. We can take this little piece, angle A, we can add it to this other portion of 50, and it'll equal the whole angle XWZ, which is 85. So that's using angle addition. You can add two angles that are adjacent to each other to equal the whole angle. So we set up this equation. Now we can subtract 50. Keeping it balanced, we get A is equal to 35. So that measurement is 35. Okay, we'll try another one. This one here, you might want to pause the video and copy this down. Okay, and then there's some notes off to the side basically connected to the picture here. In the picture we have angle ABD is a straight angle. Here's angle ABD. It's a straight line, it's a straight angle, which we know equals 180 degrees. Angle ABC is that obtuse angle, ABC, which is 110 degrees. And angle CBD is this acute angle, less than 90. CBD is X. That's what we're trying to figure out. Okay, so using the angle addition, we can set up an equation where we have the 110 plus this portion here of X, and it will equal the straight angle of 180. And in the original problem, 180 wasn't given. It was just told to you that it was a straight angle, so you had to remember a straight angle is 180. Okay, so we solve by subtracting 110, and that gives us the measurement for X, which is 180 minus 110, which is 70. All right, and we're getting close here to the end. You're doing a great job. I got one more page for you. So there's a lot of combining algebra with geometry. Even in those last couple of examples, there was a combination of algebra where we were solving for X, and then geometry was used to kind of set up those equations. In this problem here, we have one more picture, and it says in the figure, and that little M, this M right here, that just means measure. So when you see that M, it just means the measure. It's not there to confuse you. It just means measure. So this just says, in the figure, the measurement of angle 1 is X minus 18 degrees. So this little portion is X minus 18. That's not very neat, but hopefully you can see that. And measurement of angle 2 is 8x degrees. Okay? We have a straight line here, and we know straight lines equal 180 degrees. And so using the angle addition, we can take this little angle here, x minus 18, we can add it to this angle 2, which is 8x, and it will equal 180 degrees. Okay, so there's the equation. Now we'll solve. Earlier we solved an equation where we had variables on the same side. Here we have an x and an 8x. They're both positive. So together that's really 9x minus 18 equals 180. Now we have a two-step equation. Hopefully you remember some two-step equation stuff here. We have to get rid of whatever's furthest away from the variable. So we get rid of the minus 18 by adding 18 to both sides. So we have 9x equals 198. And then the last step is to solve by dividing 9 on both sides. X will equal 198 divided by 9. A little long division for you. And we get 22. All right, so that's a great start. We solved for x, but we're not finished because we need to figure out what is the actual angle measurement of angle 1 and angle 2. Well, if you recall, angle 1 was x minus 18, and we just found that x was 22, so we can substitute that value in for x. So I'll put 22 minus 18, which is 4 degrees, so it's really small. All right, so I wonder if you could figure out what angle 2 is. Well, angle 2 was labeled as 8x. So it was 8x, but we just found that x was 22. So this is really 8 times 22. And if you multiply 8 times 22, you would get that angle 2 will equal 176 degrees. And something else that you may notice is that these two add up to equal 180 because they create that straight line. Okay, I know it's a lot of work, but you guys you're getting pretty advanced with what you're learning, so hopefully we can do this. The last thing I want to show you, and I guess the video is longer than I had hoped, I apologize, but quick review. Here's a figure where we have some intersecting lines, where there are some angles that are adjacent or vertical and some are supplementary. In this figure here, there are several pairs of vertical angles. In this intersection, the vertical angles would be angle 1 and angle 3. Those are vertical. Also angle 2 and angle 4. And over here at this intersection, the vertical angles would be angle 5 and angle 7, and also angle 6 and 8. Remember, vertical angles are across from each other and they are equal to one another. They have the same measurement. And then the last part is the supplementary pairs here. There are a bunch. We have angle 5 and angle 6. Those are supplementary. They create that straight line. Angle 6 and angle 7, they create that straight line. 7 and 8. And then angles 8 and 5. And then at this intersection, we have angle 1 is supplementary with angle 2 and angle 3. Angle 3 and angle 4 are supplementary, and angle 4 is supplementary with angle 1. All right, that's it. I hope you're doing well. I miss you all, and we'll talk to you later. Bye-bye.